San Francisco's Exploratorium has announced an ambitious goal for its new museum: to produce as much power as it uses. Now, that will be especially tough because of the sheer size of the building, 230,000 square feet. But project engineers think they can make it happen. And I got a behind-the-scenes tour of this science experiment, now turning into real life. Ever since the Exploratorium opened in 1969, this hands-on science museum has been known for innovation. That tradition is on full display in the design of the Exploratorium's new home, a historic pier now undergoing a complete overhaul. Pier 15 sticks out more than 800 feet over the water, a giant warehouse-type building that could eat up a lot of power. So engineers are trying something different: net zero energy. Peter Rumsey is a true believer.
There's part research, part evangelical, getting people to get excited about it, and then just sheer determination.
Net zero means the building will create at least as much energy as it uses. The power comes from this huge field of high-efficiency solar panels on the roof. They're made by a Silicon Valley company called SunPower, and they're expected to generate 1.3 megawatts, about what it takes to run 1,000 American homes for a year.
What you'll notice differently on this panel is no glare, all black, no metal on the front. So all the sunshine that hits the panel goes into the cell.
But that's just the start. To reach net zero, the new Exploratorium will also have to use less power. The main reason that net zero approach is even possible for the new Exploratorium is because the new building sits right next to the bay and the cool water here. And in order to heat and cool the building, they're able to use this water in a very clever way. This pump room is the guts of the system.
That's the bay right there.
Bay water comes into the building through a giant filter.
We bring the water in at a very slow speed, so no fish get sucked up to it. So this is the same technology it's used in an aquarium, and there's a set of other filters inside there that get all the small microorganisms out.
Microorganisms? You're talking about at the cellular level?
Exactly.
And what's left? Absolutely pure water?
Well, not absolutely pure. There's still salt and other minerals in it.
The water is pumped to a big blue tank called a heat exchanger. Inside, state-of-the-art technology pulls heat out of the water in winter and cools it in the summer. Pipes carry it all over the building like a giant radiator. During the process, huge filters are raised and lowered for cleaning, and visitors will be able to see it all through a window.
And this room is now going to be part of the exhibit to explain how the building works.
Oh, that's fascinating. So every visitor to the Exploratorium will be able to see what we're seeing here. There will be one brand new building, a glass observatory with spectacular views. But all these windows make controlling the temperature a real challenge.
So we compensated for that by using a super energy efficient glass.
The tiny ceramic lines at the top and bottom reduce heat and make the glass visible to birds so they don't fly into it. Work on the redesigned pier is almost 90% finished at this point, but reaching net zero energy will take more time.
And we actually have 2,000 monitoring points in the new building that will help us determine what's working and what's not.
That information will be used to fine-tune the energy systems over time, with the final goal of becoming the largest museum in the country that creates as much power as it uses. Seeing it in person, I can tell you, it is a truly impressive feat of engineering. And, I want to point out now is your chance to get in the last visit to the old Exploratorium at the Palace of Fine Arts.
Yeah, it'll be open through January 2nd, then the new building is expected to open sometime next spring.
And if you do plan to visit, we have a link to what you need to know at abc7news.com under See It on TV. But go check it out.
Yeah, what a spectacular location for the new facility.